Around 10 years ago, a huge, just massive aquifer was discovered in the Turkana region of Kenya. Back then, the country's government said this aquifer could supply all of Kenya with water for 70 years. Then they found another aquifer in Namibia, the driest country in Africa south of the Sahara. Recently, the U.S. announced the discovery of 5 new aquifers in Niger containing over 150 trillion gallons of water. For comparison, Egypt's current water demand is about 30 trillion gallons per year. So it turns out that Africa has had massive water reserves all this time. But why isn't anyone using them? I mean, it's obvious that people in Africa need water. If it were all simple, I wouldn't be making this video. And yes, I need coffee. In the meantime, here's an unobtrusive reminder for those who put likes. Don't forget to do it during or after watching. See that strange half moon on the ground? Actually, it's a semicircular earth bund with a dugout pit that the Kenyans put together. This simple structure is used to collect rainwater, and it's critical for the locals to have enough of it. Without it, farming would be impossible, and people would lose their livelihoods. Now think about what people have to go through just to get some water, even though they're actually living right above huge natural reservoirs. As strange and absurd as it may sound, Africa is a continent with a massive supply of water. Look at the map. The blue spots are aquifers found on every continent containing a lot of fresh water. According to scientists' estimates, around 30% of the entire planet's supply. On the map, Africa doesn't look as dry as usual. On the contrary, it's full of water. The researchers who created this map say that many countries now deemed water poor actually possess a true treasure of groundwater. If you speak in numbers, you'll find that the continent holds almost 9% of the world's freshwater supplies. And that's Africa. The dry, always struggling with water shortages Africa. But this picture doesn't fit with the reality where Africa actually has 63 remarkable transboundary river basins that cover 64% of the continent's land area. In other words, more than half of the continent is made up of river basins. That's quite a bit. However, the total volume of water in underground aquifers is 100 times greater than the volume found on the surface. In any case, that's what scientists believe. They did a bunch of different measurements and figured out that the volume of groundwater in African aquifers is about 160,000 cubic miles. This is 20 times more than the volume of fresh water in Africa's lakes. The largest underground reserves are located in North Africa, meaning in Libya, Algeria, and Chad. The volume of water in these basins, to make it easier to visualize, I'll put it this way. If you pumped all this water out from underground and then poured it on the surface, it'd form a 246-foot thick layer across these countries. Until now, groundwater has been largely ignored by researchers, and its potential applications have not been considered. But recent maps and findings might change this perspective. To understand how to use these reserves, you need to figure out what exactly this aquifer is. To put it simply, it's a layer of rock where groundwater is stored. Most people have probably heard of it, but just to clarify, it's a term used to describe water that seeped into the soil and stayed there. It's not underground rivers or lakes, it's just, it seeped in. Since the rocks that hold the water are usually too porous, water can't move through them like a river, it's just there. And by the way, most of the water we use for household, industrial, or agricultural purposes is actually groundwater. To access it, we drill wells and then gradually pump the water out. Of course, aquifers come in different sizes and shapes. It all depends on the rock they're located in. Some can be like caves and hold large volumes of water. Others might be a few feet to hundreds of feet thick, but with several layers, like a cake. Aquifers can stretch out over many miles or be localized in certain areas. In Africa, most aquifers are found less than 164 feet below the surface. In South Africa, there are 2 huge aquifers. The largest one stretches from Cape Town to the city of Kibera, which is 466 miles away from it. This geological formation covers a surface area of 14,300 square miles and has a thickness ranging from 3,000 to 13,000 feet. The second major aquifer is the Cape Flats Aquifer. In North Africa, there are significant water reserves such as the Nubian sandstone. This aquifer covers an area of about 770,000 square miles and spans across Libya, Chad, I already mentioned it. It contains more than 36,000 cubic miles of groundwater, which is more water than the Nile River discharges over 500 years. And that's just a portion of the aquifers I've mentioned. Covering each one would take more than just a single video. Water gets into these aquifers in various ways. Some of them fill up with new sediments, while others contain old or even ancient ones. Take the Nubian sandstone aquifer system, for example. It also happens to be the largest fossil water system in the world. As you might guess from the name, fossil water is an ancient body of water that was contained in some untouched space for thousands of years. Water seeped into Africa's aquifer about 1,000 years ago when the climate conditions were very different from today. The Sahara Desert didn't exist yet, and where it is now there was a tropical forest, like a real one. For a significant part of the Paleocene and Eocene, roughly from 66 to 34 million years ago, most of what's now southern and central Sahara had a hot, wet climate, perfect conditions for growing something like the Amazon rainforests. In general, since that time, water's been underground, unaware that things have changed a bit up top. All right, we figured out where the water comes from, but how do we get it out? There are different ways to access groundwater, including hand-dug wells, drilled wells, and even natural springs. But if it were that simple, many experts agree that large-scale drilling might not be the best way to increase water supplies. The problem is that many groundwater reservoirs aren't getting refilled due to the absence of rain, so big-time drilling might quickly drain the resources. Even in the driest areas where there's very little rainfall now, groundwater can stay in the ground from 20 to 70 years, and sometimes slower methods of extraction can be more effective. So, correctly positioned and set up wells for moderate farming water needs and hand pumps are probably going to work well. And then I came across some interesting statistics. In North Africa, 92% of the population have access to safe water, which is pretty good. But in countries in Africa south of the Sahara, this figure remains at a frighteningly low level, 60%, which means 40% of 783 million people in this region don't have access to clean drinking water at all. In these areas, the daily water use per household per person is also the lowest in the world. It's much lower than the minimum personal and household consumption level established by the UN, which is just 13 gallons a day. Apart from large cities, in many places there's no water supply, so people have to depend on the only other option, fetching water. Often a family member had to spend 30 minutes or more to bring water home every single day in the heat. To collect water, they use a canister, a bright yellow plastic container that used to be filled with vegetable oil. If you fill it to the brim, it's around 5 gallons. The job is really tough, especially since the canisters are frequently carried by hand with no carts and not on a smooth, straight road. Plus, there are lines for water. At the hand pump, you can end up spending even more time there than traveling. Depending on the family size and household needs, like laundry, women might need to make this trip several times in a single day. Sometimes water is only available at certain hours, so it's not just about the walk, you also need to rush. Over time, this leads to health problems, particularly affecting the neck and back. And all of this happens at the same time as huge volumes of water are right under these people's feet. In recent years, the water situation has worsened. The percentage of people in sub-Saharan Africa with access to piped water in their homes has actually decreased from 42% to 34%. Mainly, this is due to a low amount of precipitation over extended periods. This caused approximately 90% of wells to dry up in countries in the region that were already dealing with a lack of water. And as is often the case, a shortage of something brings about shady sellers. There are now whole unregulated water markets where vendors not only sell poor quality water, but also keep hiking up the prices. What are buyers supposed to do when they don't have other choices? But as absurd as it sounds, even heavy rains don't help with the water shortage. Extreme rainfall leads to flooding, and flooding poses a serious threat to water supply. This includes infrastructure damage, pollution of water sources, and ruined drainage systems. Some countries, like Kenya, face a higher risk of landslides during heavy rains, plus during floods, the sea level rises, and this also leads to water pollution. Just when you start to wonder why people in Africa are still suffering from a lack of water despite its presence, science comes to the rescue. Science reveals that the water scarcity in many parts of Africa isn't due to an actual shortage of water. There are other reasons. Geography is largely to blame. Resources are distributed extremely unevenly. 54% of the continent's reserves are concentrated in just 6 countries, while the 27 countries facing severe water shortages have access to only 7%. It's unfair, but there's no one to blame. Another challenge is the extraction of groundwater. While South Africa's aquifers contain around 62 trillion gallons of water, much of it cannot be pumped out. Besides the geological limitations, there are serious concerns that without water, the soil will just sink. If the water table's near the shore, drawing it out can bring in salty ocean water. And that's it, the entire reserve will be worthless. Draining water from an underground cave could cause it to collapse, create a sinkhole, and people could get hurt as a result. Even river levels might go down due to depleted aquifers. Aquifers won't always help solve the water shortage problem either. For example, early research results showed that water from Turkana Aquifer in Kenya seems unsuitable for use. It's just too salty. And that's not even considering that Africa's aquifers stretch beyond national borders. So water will have to be shared. And when it's in short supply, that sounds like a huge problem. We're talking about something on the scale of a military conflict. And of course, there are the issues of logistics and cost. For instance, the distance between the aquifer and the spot where the water is needed could become a big problem. Building pipelines and infrastructure is super costly, so who's going to want to deal with that? Drilling down to reach groundwater can be quite expensive. Before drilling begins, a kind of surface scan is performed to ensure that there are valuable water resources worth tapping into. And then there's the cost of the drilling rig, and the workers' salaries, and a bunch of other smaller expenses. So water quality is an issue too. Sometimes it's contaminated by human activity. Sometimes water acquires traits from the surrounding soil, like having too much iron. I've already mentioned the potential salinity. Also, if you drill deeper than 165 feet, a manual pump just won't be enough to remove the water. You'll need an automatic, which means additional costs. At depths greater than 330 feet, the cost of drilling wells increases significantly due to the need for more complex drilling equipment. The cost might be around $130,000 for one well, though access and infrastructure issues could drive this number up. So due to the lack of investment, underground water sources remain unused or even unexplored. There's no cash for infrastructure, no experts, and no idea about what to do with these vast aquifers. But still, there's some good news. It's expected that by 2036, $274 million will be invested in the development of these aquifers in South Africa. If all goes well, they'll provide about half the volume of water in the Berg River Dam, which supplies almost 20% of Cape Town's water. Countries that share the northern aquifer have already agreed on fair usage. It's a bit simpler there. Digging riverbeds versus drought. Right now, while you're watching this video, Southern Africa is battling one of the worst droughts in recent history. About 70 million people are left without enough food and water, and where rivers used to be, there's just beige sand. To get even a little bit of water, people are digging into the riverbeds, and it helps. Along the riverbed, there are pits large enough to hold a bucket. People drink this water, use it for washing, and water their livestock with it. And to get this water, locals have to spend even more time and effort every day. Imagine having to walk 3 hours to get a bucket of murky water. Horrible. Cape Town water crisis. From 2015 to 2018, Cape Town experienced a drought that happens once every 400 years. It put the city with a population of about 4.6 million people on the brink of day zero, the point when Cape Town would run out of water, as in completely. At that time, Cape Town was on the brink of running out of water. Authorities considered turning off the water supply, which would have made it the first major city in the world to completely deplete its municipal water resources. And this isn't the kind of first in the world that's something to be proud of. The residents narrowly avoided this fate by drastically cutting back on their water use, and then the rain started. The richest city without water. In March of this year, residents of Johannesburg, Africa's wealthiest city, faced a severe water shortage during a scorching heat wave. Local businesses and even hospitals were hit hard. Nurses complained to the media that they couldn't even wash their hands. The water shortage wasn't because there was no water. Instead, the issue came about due to problems with the country's electricity supply. A lightning strike hit a crucial pumping station, causing a power outage, and that was it. Thankfully, everything got fixed in the end. You owe me just one like. See you later.